Hello and welcome to 26th lecture in the 19th chapter of our comprehensive course on AI, ML and DS. This chapter was named a comprehensive introduction of statistics, and first we did measures of central tendency and measures of dispersion. Next, what we did was descriptive statistics, and then we started inferential statistics with discussion of first central limit theorem, and once that discussion was over, then we are at present doing hypothesis testing by various tests. Now, if you remember the previous lecture, there we studied one with such practical problem that suppose you are trying three different diets, low carb, vegan and Mediterranean, for weight loss and testing the effectiveness for that. And we used one way Anova for that. Okay, so F one way Anova. Now there a few questions might have arise in your mind. One is that why one way ANOVA? And if this is one way ANOVA, then is there any two way ANOVA like that? Okay. And second question may be here p value. It is looking like it was looking like 0, right? So that question may arise that it is 0 looks slightly unlikely. But the second question is easier to tackle, so I'm doing that first. That is because we have actually formatted our output of p-value to 4 digits after the decimal point, right? So if I just remove this formatting and then print the p-value, then you will see that there is some small value, that is 0.00007 zeros, and then 131. Okay, so we are getting 0. That does not mean that the data set has, since it is synthetically created data set, p-value comes out to be 0, right? But it is very small p-value and less than significance level. So we rejected the null hypothesis. That null hypothesis says that all diets have equal effect, or that means the change of diet has no effect on the weight loss. That is what mean weight loss remains same. But no, we rejected null hypothesis and we found that the type of diet affects the weight loss. And then we even plotted this kind of diagram. Then the median weight loss for Mediterranean diet was highest. Mean weight loss for Mediterranean diet was also highest. And from this chart also, which is pairwise scatter plot also, the weight loss was highest for Mediterranean diet. Now the question, now I am tackling that first question. Okay, that why one way ANOVA? One way ANOVA is used when you are comparing three or more different groups, but you are comparing effect of only one parameter. So that's why the name, one way ANOVA, right? So that means here what you did, whosoever say 90 customers came in my gym, I divided into three groups of 30 customers who were put on vegan diet, 30 customers who were put on the other Mediterranean diet, and the 30 others who were put on low carb diet, right? And then I studied the effect of diet. So there is only one factor, that how diet affects the weight loss. So weight loss is my response variable and diet type is my the feature variable. But every time it is not necessary that there is only one feature variable, right? Here only one feature variable is there, so one way ANOVA. But when two way ANOVA would be required, suppose I further divide my 90 customers into gender. So that means 33 groups I make and try each type of diet on them. But also in each group I mix up the gender. So that means in first group which was put on low carb diet, say there are few males and few females. Similarly, second which was put on Mediterranean diet, again few males, few females, and another which was put on what type of diet? Yeah, that was vegan diet. There also few were males and a few were females. So now I am not studying effect of just diet type on the weight loss, but I am studying effect of diet type and gender on the weight loss, right? So there actually two way ANOVA would be required. Not only that, but what will happen is whenever two features are there, diet type and gender, then those two features also interact with each other. Now that interaction effect, if you want to study, then then also you will have to use two-way ANOVA. So two-way ANOVA is used when there are two independent variables which we want to evaluate their individual effects on the dependent variable as well as their potential interaction effect between those two independent variables. So here what are my independent variables? The diet type and the gender. And what is my dependent variable? That is the weight loss. How much weight loss will occur? Okay. So this is that example which I just now described, that put the three groups on three different diets, and also in each group a few observations should be male and another few observations should be female, right? And in that case two-way ANOVA will be needed, right? So actually you are studying three different effects. One, effect of diet type on weight loss. Second, effect of gender on weight loss. And third, interaction effect between the diet type and gender. That means these two independent variables, how they two depend on each other, right? Then a two-way ANOVA will allow us to study all these three effects, diet type on weight loss, gender on weight loss, and effect of gender on diet type, or effect of diet type on gender. Both are one and the same thing, interaction effect, right? So here we start first with an approximate method. Here I am still using one way ANOVA because I have to find some hack of doing something for two features, because one way ANOVA is as such usable only for only one feature, but I want to use it for two features, right? So what I am doing is I am creating samples for each diet, but in the previous case, I just created 3 samples for the 3 diets. Let me clear this output because I have to scroll a lot, right? So then these two, and maybe these also. So we created 3 samples, one sample for low carb diet, one sample for vegan, and one sample for Mediterranean, because at that time the gender was nowhere in the picture. But now in low carb also I will have to create 2 samples, one low carb male and low carb female, one low carb vegan male and vegan female, and one Mediterranean male and Mediterranean female. The advantage of doing it that way is that I can use one way ANOVA, because one way ANOVA test clearly says that it is used to compare the means of 3 or more groups. So now I am making 6 groups, okay, and then I will compare the mean of all 6 groups. So that is a kind of approximate method, but it works, and we will do it by one way ANOVA by making 6 groups. So this is my first group, low carb males, okay, and these are their weight losses. I am directly giving weight losses. Then this is my another group, low carb female, and these are the weight losses which were observed in the gym. Now here I am creating the data synthetically, but there the gym owner will provide you with this data. Then this is the vegan male weight losses, and this is vegan female weight losses, Mediterranean male weight losses, and Mediterranean female weight losses. Now perform two-way ANOVA, but I have written here that in practice you will require states model type another package. So that means that SciPy library is not enough. You will have to use another library, that is states models library. But we don't want to go into that. So we will perform one way ANOVA across the 6 diet groups separately. But that means interaction effect will not come, because we are taking each group independent of each other, right? So we will not be able to study interaction effect, but we will at least be able to study the effect of both type of diet and gender on my response variable, which is my weight loss, right? And what will be my null hypothesis? Null hypothesis is that weight loss does not depend upon the type of diet, and weight loss does not depend upon gender. Okay, while alternative hypothesis is that weight loss does depend upon type of diet and gender. So if you plot this, then you get F statistic pretty large. So just like whenever you get T statistic or F statistic pretty large, it is sure that mainly p value will be less than significance value. So p value came out to be 7.88 into 10 to the power minus 13, or that means it is that 0.000012 zeros and 788. But in short, that p value is less than, p is here clearly less than, in fact it is much less than, if I write it this way, 0.05, my significance level, and therefore I would say that null hypothesis would be rejected. So somehow this different diet and different gender, they are affecting the magnitude of weight loss. But you can see, though this approximate heck worked, but it has many limitations. One is that it does not show effect of each factor separately, that what is the effect of this diet and what is the effect of gender. That is what it does not show. And the second thing which it does not show is that what about the interaction between the type of diet and the gender, that is the 2 independent variables, they all also interact with each other. So that also it does not show. Now suppose someone insists that I want to do pure, without such approximation or without such hack, I want to study the same thing, that I want to take several different observations and put them in 3 groups who will be subjected to vegan diet, low carb diet, and Mediterranean diet, and in each group there will be both males and females, and I want to clearly study the effect of both independent variable on my dependent variable, that is the weight loss, and also study the effect of interaction effect between the 2 independent variables, that is how gender affects the interaction of other with the response variable. So other is the diet, but diet's interaction with the response variable is affected by presence of another independent variable, that is gender. And similarly, gender's interaction with the response variable, that is again weight loss, is affected by the presence of previous independent variable, that is diet type. So what we do is we create a data. Now the data is like this, that first we create one column, and in that column we just concatenate several arrays, right? Okay, so that is, one is this array, which is the array which gives the weight loss for low carb males, and this is this array, weight losses for low carb females, vegan male, vegan female, Mediterranean male, and Mediterranean female, and concatenate all of them and multiply by 5, so that that means here there are only 5 rows for each. So for statistical significance, we know that at least 30 samples are required. So we create identical rows. I just don't want to waste my time. That's why I created identical rows multiplied by 5. So this same set of data points will be repeated 5 times. Similarly, these also each will be repeated 5 times. And then I put them in 3 columns, weight loss in one column, diet in another column, and gender in another column, and I create my data frame. So what I do is I will first do the printout of only this much, right? Okay, so I got this kind of data set, right? In which one column is the weight loss, which is my response variable. One column is diet, in which there are 3 categories: low carb diet, vegan diet, and Mediterranean diet. And for each type of diet, there are 10 rows. And another column is gender. And you can see that for each category, low carb, for example, if I see the gender, then there is a mixture of males and females, right? So I got the required data. Now, such a data here we created synthetically, but you should not worry about where to get that data, because that data must be provided by the owner of the gym. So if he has provided you with such a data and you want to study the effect of these 2 parameters, diet and gender, independently, how they affect weight loss, and also how diet affects the interaction of gender with weight loss, and how gender affects the interaction of diet with weight loss. So that means their mutual interaction affects their individual relation with the response variable. So that is called interaction effect, and that you want to study, for which I will use the states model library. So far, up to the creation of this data, it is ordinary pandas, numpy, only 2 libraries are used. But now these 2, they will also be used. So from statemodels.api, we import SM and import statesmodel.formula.api as SMF. So this is 2 things. And since they are imported from using API, so that means internet must be on for using them. Okay. So it will throw some error. So immediately you will understand that some error is thrown. So internet must be on. Now, where is the use of that library? So the use is here. That is these 2 libraries. The use is in this there. That we create a model. Now you can see that that means two-way ANOVA is not that simple, right? You have to first create a predictive model. This is called OLS, or that is called ordinary least squared regression. Now we had done detailed discussion of ordinary least squared regression earlier, but just for the sake of a reminder, I will show only the diagram to you. So this was the diagram, right? Here, this is my one independent variable, that is say x, and y is my dependent variable, and I have plotted y versus x graph. These are my actual data points, and I try to fit a line, straight line, which is as close as possible to the majority or all the data points. And as close as possible means what? Then I take that you find the actual value of the data point, which is this dot or this dot, its vertical height, and you find the predicted value of that data point. Predicted values are all on this green line, because green line is my model. So the model will always predict what values are there on itself, right? So then you find the difference between them, y predicted minus y actual, then square it. So square that. Similarly, for other point also, actual minus predicted whole square, for other also actual minus predicted whole square, and then sum of those things. So that is sigma actual minus predicted whole square, and divided by, that is called sum of squared errors. And you should select such a line which makes the sum of squared error minimal. So that means that is the meaning of word, that the line should be, line of best fit means the line should be such that it is closest possible to all the data point, or that means the sum of squared error should be minimal, right? Now here it is same situation in our example, that we wanted to study weight loss. So on y-axis there will be weight loss, and on x-axis there will be diet. The only thing which is complicating the matter further is that there is another parameter also, and that is gender. Now that means if we want to plot similar diagram, then it would be a little bit difficult, because now there are 2 independent variables, not 1 independent variable, right? So it would be a 3-dimensional plot like this, in which this would be x-axis, on which I will put the say gender G, and this is z-axis, which I am deliberately showing by some different color, on which I will put the diet type, okay, so which I am showing by D, and on this axis is my response variable, which I will show by weight loss, WL, okay. So weight loss is on my this axis, and diet is on this axis, and gender is on this axis, right? So if I do it that way, then in that case I will get a plot which is similar to this, but in 3 dimensions. And just like here we get a line which is the closest possible line to majority of the data points, here the data points will be spread in this entire space made by x-axis, y-axis, and z-axis. So that means that data points will be spread on xyz space, right? So then you have to find the plane which is closest possible to all those data points. So that is how you will do it in 3 dimensions. So I will show you one diagram for that, okay? And because it is difficult to draw for me that way, so I will find out a diagram and show you. So you will get this kind of diagram, right? This is that famous example that sales is plotted on y-axis, this here, that is this axis will plot the sales, this red colored axis, right? This is x-axis, which plots my TV marketing expense, and the inner one or outer one, z-axis, that is plotting my radio marketing expense, and I want to predict the sales. So that these are the data points which are in the XYZ space, and if I want to find the a plane which is closest to all the data points, then again I can use ordinary least square regression. So it is not that OLS is useful only for one dimensional case. Sorry, that means two dimensional case. It can, or one independent variable. It can be used for two independent variables also. And at that time, this is not called line of best fit, but this is called a plane of best fit. So this plane is the plane which is closest to majority or almost all the data point, and that means sum of squared error is minimal for this plane, right? So here, instead of that radio marketing and TV marketing, just put our two cases. So our variables are, instead of these TV expenses, you just write that on x-axis you are putting gender, G, and on z-axis you are putting the diet type, okay, and on y-axis you are putting your response variable. So that means that weight loss, WL, and then you plot the graph. Then that kind of graph will be optic. So these values are now okay. I'm cancelling that old axis and I'm putting my axis. So it becomes the graph like my case. Then these ordinary least square regression, the question is that now these things are looking to be more and more complicated, because for at least one plane and finding that line was looking easy, even if I have to do manually and suppose there are limited number of data points. But now in a plane, and then suppose there are three variables, three independent variables, then you cannot even draw the diagram. So the question of finding manually does not arise. But fortunately, you don't have to do this process manually. That take each data point and find its actual value and predicted value and find the difference of that, and then square it, and then similarly square the error in all of that, and then do sigma, the sum of squared error, and then minimize that sum of square error, so that you will get least squared line, a line which is giving the list of squared errors. So minimum value of the squared error. You don't have to do that manually, right? You have to just use a simple equation. From SMF, that is states model formula, that is this library, you dot OLS. OLS means ordinary least squared, and take your dependent variable on one first, then this is a tilde symbol, and then take your two independent variables as multiplication of each other, right? And so this is which is my dependent and what are my independent variables. That is the first argument to this function. Second argument is which data set I have to take. So data set is this, the diet data set for 3 diets and 2 genders, right? So if I perform two-way ANOVA, then how to perform two-way ANOVA? Then sm.states.ANOVA lm. Where is sm.states? We have imported that here. So smf and statsmodels.api as sm. So sm.states.ANOVA lm. So remember, it is not called clearly two-way ANOVA, but it is called linear model ANOVA. And linear model should not create that wrong idea that it is always a line. It can be a plane also, right? Because in this case, actually, it will be a plane. There are two dependent variables like this. Okay, so then print the ANOVA table. So if you print the ANOVA table, you get the sum of squared for variables, then you get degree of freedom, and you get F statistic, and you get PR. Now, what is the meaning of this ANOVA table? That also we are going to see. But first, let me put visualization, because with visualization, it is even easier to understand the meaning of this ANOVA table. Okay, so my purpose was that I now do not only want to study the effect of diet types on weight loss, but I want to study effect of diet type and gender on weight loss, right? So I am plotting this kind of graph, and you can see very clearly, first graph is the box plot, which shows that for each diet type, low carb or vegan or Mediterranean, there is a marked difference between how much is the effectiveness of that diet for males and females. Green is male, orange is female, and in that case you can see that males usually lose more weight for low carb diet, while females lose more weight, less weight with low carb diet. But for vegan diet it is reverse, that females use more weight and males use less weight for vegan diet. And similarly for this Mediterranean diet also, males lose much more weight compared to females. Okay, so that means now you get more insight that you will not blindly recommend Mediterranean diet from your previous one-way ANOVA. You got that Mediterranean diet is best for weight loss, right? What is the problem? I think I will have to create all these variables. Okay, I cleared all those, but I want to show what is the greater insight. Yes, here we got this, that Mediterranean diet is the best among the 3 types of diet. But is it that simple? No. Now you are getting better insight that Mediterranean diet is the best, but it depends upon how much will it be effective for this, depending upon the gender. For example, for female, Mediterranean diet, the median weight loss was somewhere 3.5, slightly more than 3.5 kg. But surprisingly, low carb diet worked the best for that. Okay, of course, these are two different data sets, but the point is that you have even the gender affects the how much will be the weight, how much will be the weight loss. So you have to take into account what is your gender, and perhaps for same diet, Mediterranean diet, you should promise accordingly. If the client is male, you can say that you will get good results. Client is female, then you should say moderate results. And perhaps female client would be better off putting her on low carb diet compared to Mediterranean diet, right? So that is what the greater insight you are getting. Also, this interaction plot that shows that this blue line is for females and this green, orange line that is for male. Now, if these two would not intersect anywhere, then in that case you will say that gender does not interact with the that is male do not interact with female. Do not interact with female means what? Male do not interact with female so far as their relationship with weight loss is concerned. So I said that diet affects the weight loss, but its effect is also modified by gender. Now, whether it is modified by gender or not, if these two lines do not intersect anywhere, parallel lines, then you will say that no, gender does not modify the relationship between weight loss and diet. Similarly, if the lines would be parallel, then you will say that okay, weight loss is affected by gender, but the question is, does the diet modify the relationship between weight loss and gender? Then if the lines would be parallel, this line, then you will say that no. But here lines are not parallel, they are interacting with each other. So you will say that diet interaction of each independent variable with the dependent variable, that is weight loss, is also modified by the presence of another independent variable, right? So that is what it is. Now about the Anova table. What is that Anova table? Let me copy it here so that it remains in front of you while I discuss it. Okay. So here I will make, this is explanation of code, so that I don't need, that anybody can understand. But this is the Anova table, right? So this was my Anova table. Just as a markdown, I put it like this. Okay. So if I see this, then diet p-value 4.33 exponential minus 13. So if someone says that does diet affect the weight loss, then yes, absolutely, because this is very small p-value. In fact, it is 0.0000012 zeros, and I'm not counting 12 or not, but that is 12 zeros and 432, right? So it is much less than the significance level, that is 0.05, or that means null hypothesis that diet has no effect on the weight loss, that would be rejected. Diet does have effect on the weight loss. Now about this particular gender, here the value is 4.18, or that means it is 0.0418. Now that is still less than 0.05, but this time I cannot say it is much less than, like this. Okay, it is just a bordering. So that means gender has some role. So again, it says that gender affects the weight loss, but its effect on the weight loss is not as strong as the diet. Okay, and that is what is discussed about gender. P-value is below the threshold, meaning that gender has significant role, statistically significant. Here, significant does not mean large or small. Okay, significant means whether you will consider gender or not consider gender. Then yes, you will have to consider gender while advising your client, and this is also called significant. So means you will consider the type of diet while advising the client. Then yes, you will have to consider the type of diet, and maybe you will advise either Mediterranean or vegan diet, right? So that is what is clear. So it has strong effect because this p-value is much less than significant level. So null hypothesis is very strongly refuted. By here, null hypothesis is refuted, but the effect is not very strong. Okay. Now then there is something which is here. This diet multiplied by gender interaction, that p-value. So that is this diet colon gender, right? So that product, does it affect the weight loss? Then yes, actually it is affecting much strong than gender alone, right? So 0, 0, 0, 0, I think 6 zeros will be there, and then 141. That is the value. So again, it is much less than this 0.05 significance level. So you can say that gender was as such not much. If I would just use different gender samples, but same diet would be applied to all the all 90 members of my gym, then in that case, gender alone would have mild effect on the weight loss. But if I take 90 samples from my gym, 90 members, and I try different genders, but along with that, I tried 3 different diets also, then suddenly the effect of gender, which was taken single-handedly, mild, suddenly becomes very strong, right? So that is the meaning of interaction between independent variable, that the interaction of gender with the weight loss is strengthened in presence of other independent variable, that is diet type, right? So this is what is that, and residual is fine. So I don't think that that is required. So we were doing the interpretation of Anova table, right? So fine, this is okay. Then box plot interpretation is easy. This is also easy. You can just read through it. because you are going to get this Jupyter notebook. So then conclusions. Conclusions are what? First conclusion is that both gender and diet significantly affect. Significantly does not mean large or small. Remember, significantly means whether they affect or not, whether their effect is statistically significant or not, right? Okay, so they do affect. Then in effectiveness of diet in promoting weight loss, that also depends upon gender. Now that is also clear from this interaction, and that is also clear from this box plot, that how effective a given diet is, that does depend upon gender, because you can see market difference between the weight loss for same diet but for two different gender, right? And then you will say that uh, hmm, what else? Yeah, so that means what are the practical implications? So ultimately, your gym owner will not be interested in all this lengthy discussion which we have been doing in previous lecture and this lecture. He will just say that tell me three recommendations which I have to give to my client. So first, three results which you will tell to your gym owner is that diet recommendations should consider both diet type as well as gender, right? Then second, for males, a low carb diet or Mediterranean diet looks more effective. That is clear from that box plot. For males, green, low carb diet or Mediterranean diet is more effective, while vegan is completely very less effective. You can see that weight loss is less than 2 kg, right? Okay. And then for females, vegan diet appears to be most effective. So female clients are usually find it stubborn to lose the weight, but vegan diet is greatly effective compared to male clients. Okay. However, you can see that still in absolute terms, whether you will recommend vegan diet or whether you will recommend, because this female has to be compared with this female also, other diet, and then with these females also. So you can see that low carb diet is in fact more effective for women also. So that means low carb diet appears to be more effective for both males and females. But for females, vegan diet also or Mediterranean also performs well, right? Okay. Now that is the three results which you will give. So only these three results are your findings. And if the gym owner is trusting you, and if your data is honest and without any error, then in that case, his clients would be super happy after this kind of recommendations, right? Now we will take that chi-square test. So actually we wanted to take chi-square test in this lecture, but I took this as a sort of bonus lecture because one-way ANOVA came. So somebody may find that what happens if two-way ANOVA. And in any case, the next chapter begins with this OLS only. So I'm not doing anything extra. I'm just doing this will be the beginning of the next chapter. So how things are related with each other, that you should understand. So whenever one simple example is given, one should try to think that okay, weight loss and the type of diet they are affected this way. But what about if my client is male and female? Then will this effect last same? Then you can still add third factor, the age of the client. So that means okay, now I have studied the effect of both this particular, that is the type of diet here at the bottom, three types of diet, and the gender, green and orange. Now the question is that will the age of the client affect the effectiveness of the diet? Then yes, it does affect. Actually, medical science says that as one is, if one is young, he has more muscle mass and it is easier to lose weight because muscles can burn the energy quickly, right? And of course, that person will be able to work out also easily compared to maybe this person. Suppose another person who is pretty aged and therefore his muscle mass is less, so energy burning rate, metabolism rate is also low. So age affects. Then suppose I add fourth factor, that with diet if workout is added. So workout yes and workout no, two more groups. Okay, just like gender, male and female, workout yes and workout no. So now how many factors are affecting the weight loss? So weight loss is affected by one, type of diet selected, two, gender of the client, three, age of the client, and fourth, whether the client along with diet is also doing workout or not doing workout. So weight loss is a pretty complicated medical problem, and that's why there is millions of dollars of weight loss industry. And you will be surprised, but this kind of analysis is done before putting the next miracle remedy for weight loss in front of people, right? Okay. So now in next lecture we will do chi-square test. So thank you and see you in the next lecture.